Yeah, hi everyone. I hope you had a nice weekend. I saw you all submitted your project proposals as you were supposed to. So this week I will be trying to get through them and give you some feedback on your projects. So like I said, the grading will be rather generous for the proposals because the main goal is really to have a plan and to see what you're working on. So yeah, with that, lecture-wise, today we are finally starting to cover multi-layer perceptrons. That is multi-layer neural networks. Has been quite some lectures to get here, but I hope all the previous lectures were useful for providing you some foundation. And now we are getting to the fun part where we will be working with deeper and deeper neural networks, now the multi-layer perceptrons. Then we will look at some tricks to make the learning more stable or better. And then we will move on to convolutional networks, recurrent neural networks, and then the generative models. All right, with that, let me get started then. Yeah, for today's lecture, there are two main points. First of all, today we will finally be able to solve the XOR problem. So the XOR problem is something I introduced earlier, a long time ago when we talked about the perceptron. So that is a data set that looks actually very simple. It's only two features, but the way these classes are arranged, the perceptron, Adeline, and logistic regression classifiers that we covered wouldn't be able to solve it, but the multi-layer perceptron will be able to solve it. However, XOR problems are not super interesting because, where do you encounter an XOR problem in real life? So in that way, we will also see how we can classify cats and dogs using a multi-layer perceptron from, image data. So the broad topics I have in mind for today is introducing the multi-layer perceptron architecture, then talking a little bit more about the different nonlinear activation functions. So one nonlinear activation function you have already seen in the context of logistic regression. Actually, you have seen two. You have seen the sigmoidal logistic or logistic sigmoid. It's probably the more common way to say it, the logistic sigmoid function. And you have seen the softmax function. The softmax function is usually something that is used before the output layer, but for the hidden layers in a multi-layer perceptron, there are different choices for nonlinear activation functions. The logistic sigmoid would be one of them, but we will also take a look at some other ones. Then I will show you some code examples implementing a multi-layer perceptron in PyTorch. And then we will talk a little bit about overfitting and underfitting. So these are really important topics. Underfitting and overfitting, that's related to how well our model fits the data. Fitting the data not well enough is of course bad, but also fitting the data too well can also be bad. And then finally I will show you how we can apply this to a cats versus dogs data set. So here I will introduce how we can use custom data loaders. So that is something I think you will find very useful when you will be working on your own projects where you have your own data sets. Of course, a multi-layer perceptron is not great for image data. For that there are convolutional networks, but introducing one thing at a time, we will first apply our multi-layer perceptron to this cats and dogs problem, and then later we will use convolutional networks to solve it a little bit better. Alright, so that is the overview, and in the next video I will start explaining the multi-layer perceptron architecture.